Okay, so I'm going to talk about expert systems, which is a sort of big AI type word. And the formal definition is to do with knowledge bases and inference engines. You get this knowledge base and this inference engine by talking to an expert. Actually, what at the end of the day we're talking about is some tables and some if-then-else clauses. Yeah? So that's basically what we are doing with an AI. Now, my introduction to lift traffic calculations, actually this is an extract from the ARP. We've got some ARP people here, I think we have. ARP design guide from the early 80s. And I was presented with this. Oh, Roger, you'll know this. And I was given this as well. This was a table. And I was expected to fill this in doing my lift traffic calculations. And the younger people among the audience today will say, well, why didn't you use a spreadsheet? Obviously, it's a spreadsheet, isn't it? But actually, the spreadsheet was only invented in 1979, and it hadn't really reached engineering offices in the early 80s. It did later on. And Gina's shown you what you can do with a spreadsheet, and I was desperately excited about spreadsheets when I was able to use them for engineering. But having done some software programming as a child, and I had one of these things. Does anyone have a VIC-20? Yeah? It was a dreadful machine. I wanted a BBC Micro. My father bought this one, and anyway, I've made all the computing decisions since then. So I knew that I could actually implement all that in software. And when I was at ARP, I was introduced to this program called the LIFT program. Anyone remember the Oasis LIFT program? Oh gosh, I must be old. Roger does. And that would do an up-peak calculation. And to give you an idea of how far it went back, this is how they did it. They had to have the punch cards, and it took about 16 cards at 50p, and the computer time cost about £1. And today's price, that's about £10. So that was and these are the punch cards. Anyone use one of those? Yeah, I'm definitely not the oldest in the room. Yeah. That's where we came from. But that actually was a sort of simple expert system, and you inputted all the data and it gave you an answer. I've highlighted one of the results here. This is a high-rise office block where you've got a 1 meter per second lift. So it's done the calculation, but it really isn't an expert. Yeah, so it does include some sensible answers in the result, but it isn't an expert because it hasn't realised that actually it's not just interval and handling capacity. It's called 5-minute ratio and waiting interval, but those are what they are. It doesn't just include those. It's actually to do with travel time as well. So we've got the beginnings of expert systems, and that's actually where I did my first commercial traffic analysis, and I got involved in the Oasis LIFT program. We introduced multiple types of analysis and general analysis, two-way traffic analysis, and so on. And I played around then. This is it's the 90s with automated systems. So actually, I had auto AI type things in Oasis LIFT many years ago. And it gives you a sensible set of results. Yeah. Beyond that, I was talking to Rory earlier, about 15 years ago, we also did a calculator for the ThyssenKrupp website. We sat down and we did something similar, but we had to sit down and think about the rules. What's the criteria? Because we can automate all of this calculation that Gina's talking about. We just need to know the criteria. That's the difficult thing. And just to acknowledge that I'm probably not the only one working this field. I know I went on the Coney website. Here's some Coney traffic analysis people here. I don't know whether they actually wrote this, but on the Coney website. And there are sort of automated systems which will give you solutions. So that's just a little preamble of sort of my journey in expert systems for lift traffic design. The reason for this paper came about because of the revised ISO 8100-32, where we're trying to develop this traffic analysis standard. And Gina's already mentioned this graph to you here. And Gina particularly didn't like this graph. And I'll explain to you why in a moment. But why there are some issues with it, but we're very grateful to have the generation of that graph presented last year. So we do actually know exactly how that's generated. The issues become, what are the rules behind it? And particularly here, we had a debate about, okay, well, if you've only got 20 or 30 people in the building and it's at 9 floors high, do you really need 2 lifts? And Gina's calculations suggested you didn't need 2 lifts. So why is that showing that? So there was a little bit of a misunderstanding, I think, about what the rule set was behind the generation of these. So Gina, well, actually, it was Sam and I said to Gina, if you can tell us what your expertise is, well, we can build software to do exactly what you do. Yeah? All we need to do is ask you enough questions, and when we get it wrong, you just correct us, and we just add another rule, and we correct it. We go round and round in circles until we get to the point that the software does exactly what you would do. And that's what we did with Gina. I'm going to go through very briefly some of the tables and the assumptions, and then this is the output of this particular expert system. So welcome to the mind of Dr. Uranj Ginabani. This is, we've extracted from her how she would do a traffic calculation today. It varies over the years, but this is today's, the current state of affairs. The maths and stuff is all covered in things like the handbook and CIBSE Guide D, so I'm not going to talk about that. But what we need to start with is a whole load of tables. And Gina's put some of these tables, in fact you've got some of the tables in front of you on the yellow sheets. And we need to know things like the door widths and what type of door width you're going to have in the different car sizes. We need to know the passenger transfer times according to the door widths, which are going to change. We're going to work out, we want to know, Gina's already talked about how much space a person takes in a lift. And if we're going to account for mass as well, we wouldn't do mass only, but if we account for mass as well, we'd have that. Then we've got to decide what our lift speed is, and that's this table here. And Gina asked for the standard numbers, so that helps us decide what lift speed is. And then we need to, need to talk about flight times, and this is a flight time table. I'll just take a little side discussion about acceleration and jerk. You'll note those who are really into traffic analysis will note these are quite low, aren't they? Yeah. I did a whole load of measurements, and then Mark Davis has also done a whole load of measurements on actual acceleration and jerk in buildings. It's not what you think. It can be achieved what's in Guide D, but what's most of the time being delivered is these sort of levels. So we anticipate in Guide D that will actually get changed the next revision. Start delays. Door and open closing times, so we've selected the door width, and then we can have the door and closing times, side and centre opening. And notice here we've got extra things explaining that we're having centre opening for offices and then and hotels, but residential will be side opening, so we need to know all that information. Pre-opening time, 0 we're going to assume. And then we've got the required handling capacity, and I think Jeannie has already covered the fact that we're looking for a target. We're looking for the minimum handling capacity that we'll accept. We can't have a range unless you want to label that range basic, standard and luxury or whatever. You actually would need to label that and be an input to the expert system. And then we got an interval that we require. And we need a table of acceptable loads and the platform area according to those loads. And Gina's already mentioned about the loading not exceeding 80%, which is a big discussion itself. In the paper I've talked a little bit about the procedure, which is slightly different with software. because you've got all these edge effects. At stage 4 here, we might, the manual calculation might say you need just over 4 lifts. And a human would know that actually 4.05 is 4. Yeah? And when you go to stage 5, if you carried on with 4 rather than 5, you would actually, the solution be okay. So I don't want to go into the detail of that, but there are subtleties in the way that you will implement it in software. And then we get to the fuzzy bit. So interval of 30 seconds. Well, is 30.1 okay? Or is it 30.2 okay? What is your actual limit? How far can we push it before you actually reject it? So we forced Gina, put in an arm lock and said, how far can I push it? And she said 10%. So if it says 30 seconds, actually what she really means is 33. And if she says a car loading of 80%, what she really means is 82. And Sam would say to me, well, just give us the limit. It is actually a hard limit. That's the difficult thing. It's a hard limit. At some point, we will go from one solution to the next. So you have to know how fuzzy your boundaries are. Having done that, software will generate all these tables. So you can literally say, this is for an office building, 3.3 meters, and then 12 floors, 30 people floor, then 450. Notice that's the smallest car size. We'll come back to that later. That's a hotel building and a residential building. And of course you could represent that graphically, and Gina's shown you quite a nice way of representing that graphically. Which is great for standards and books and things like that, but in the real world you probably just enter the information into a bit of software and it'll give you the answer, implementing all those rules. So some of Gina's notes were, you can't replace the judgments of an experienced practitioner, even when you've got something like this. I would probably disagree slightly. You could, but you'd have to ask more questions. So, for example, in an office building, I think the example I took came up with a 450 kilogram lift. I don't think anyone would put a 450 kilogram lift in a major office building. You'd probably put, in a 2 or 3 story, you might put 630 kilogram office building, but in a higher one, you might have 1,000 minimum, and in an American big building you might put a minimum of 1,600. All that can be programmed. We just need the rule sets. So all that needs is, okay, if we're an office building and if it's if it's greater than 4 stories, then we will have a minimum car size of this, and if it's more than that, so that can all be programmed. In a residential building you might have stretchers and coffins, so you need to allow for that. And you might have an instance where the lift service is absolutely crucial, so you can't afford not to have a lift there when a lift goes out of service. So you might put 2 in, even though the calculation says you need 1. So these tables don't actually address that. They give you the minimum, and then they're still requiring some expertise from the user. And there are all sorts of architectural considerations as well. And Gina would obviously go on and use simulation to test the solution with simulation. So an expert system, as far as it goes, it is just a starting point, and you could add many other things to it. That's as I anticipate that we will do. I wanted to go back to this graph. So this is the point where we're arguing whether or not this curve really, I think, should actually carry on up here. Because this is for the ISO standard, I was really keen that we got it right. So I implemented these curves myself based on what Marilise and Mirko presented last year. And you can see my version of it, that curve does go all the way up there. And when I asked, of course, actually that's a zoom in, so that's the one in the ISO, and that's the one I generated. When I've asked, there was actually an extra rule which I didn't know about. So there was a rule within the software which wasn't on the list of things, and so we do actually need to understand the rules that our expert systems are using. Otherwise, we're just accepting things that someone else has put in. So I added that rule in again. And so now I'm consistent with the ISO graph. The other interesting thing is, for me, is here. They're only fixed at each building height. We've only considering one lift speed. And if you look at this point here, where we could end up with, I've got 4A, which is 6 persons there, and we go to 8 persons there. But actually, if I'd considered the 3.5 metre per second lift, I could have kept with a smaller car. So I think, again, all these things, I think a real designer, a real human would actually take a wider range, would consider more speeds. And this is from the draft ISO, and you can see we've got prestige, standard, basic. This is the target travel time. And actually, we could implement this to say, actually, my travel time needs to be between 20 and 30, 25 and 35, or 25 and 45, depending if you're office, hotel, or residential, in which case your graph would look like this, which is more beautiful, actually, I think. But it's actually closer to what I would do. So to wrap up, how long have I got? 2 minutes, a wrap up, okay. Okay, sorry. No, you mind. This is a picture of Sam. If you can tell us what you're going to do, it can be implemented. Yeah, we need to know the rules, and you need to be transparent about them. So we're working on the implementation of all these things in expert systems, where they're not ambiguous. Where they're ambiguous, we have to fill in the gaps. Gina's expert system was an up-peak calculation. Of course, we could do other traffic mixes with the general analysis, and just to get in Monte Carlo simulation for LUTFI's benefit, of course, we could do it with Monte Carlo simulation as well. And, of course, dispatcher-based simulation. There are risks of de-skilling engineers, yes? This is the conclusion of the written paper. In the foreseeable future, not every scenario exception will be anticipated by software developers and the human experts they consult. So there are things that we will miss for the foreseeable future. So actually the transparency of the data set and the rules applying need to be transparent. Otherwise, if you're using the expert system, you've got no idea why decisions are being made. When you're doing an expert system, when you're using an expert system, whose expertise does it encapsulate? I've talked about one with Gina, and if all these other people did their own expert systems, they would give you different answers because they have different expertise and different opinions. Don't worry, we're not going to replace you. This is a graph from the BBC about the probability of engineers being replaced by AI. And we are very unlikely to be replaced. If you are a taxi driver at the moment, I'd be worried. But as an engineer, there's always going to be work for you. If you're a surgeon, I'm not so sure. So I'm not aiming to replace you, but hopefully giving you tools which will make your calculations easier and faster to implement.